So a quick review that non-specific immunity comes in the form of the skin and its various safeguards around the openings, and the inflammatory response, which basically is a way to kind of enlarge the battlefield and put some things in place that can fight things non-specifically. Phagocytes we talked about as kind of the ninjas of endocytosis, pulling stuff in and destroying it and themselves. And then fever, which slows down the bad guys and speeds up good guys. And interferons, which are specifically antiviral. From here, we take kind of a path that splits a little bit. From here, we are going to go in two directions, starting the same way, but then splitting into what we call cell-mediated immunity and then humoral immunity. So we'll come back to this picture, but that's kind of the overview. So these are your specific defenses. They all involve white blood cells. And whichever path we're going to take, whether it's cell-mediated immunity or humoral immunity, we're going to start the same way. Don't write animation, by the way. That's just something for me to click on. Macrophage, you'll notice, has the same word bit. Phage, by the way, means to eat. So a macrophage you can kind of think of as the phagocyte's big brother, and works a little bit differently. If you thought swallowing up a bunch of bad guys and then self-destructing was creepy, you just wait. First, I'll show you a little video. This is actually just a little video ad for an animation company, but it's a nice interpretation of what a macrophage does, and a phagocyte for that matter. It's very short. This is a bad guy, and like I said, kind of just lassos these things in. All over the place. But in the case of a macrophage, the ending is different. It's going to swallow a bunch of the bad guy, but it's not going to self-destruct. Okay, this is the best analogy I can come up with, so bear with me. It's going to be creepy. Ready? You ever seen like a movie about a serial killer, and the serial killer like takes trophies, like pieces of his victims? Okay, so macrophage, literally, you know, we're like the way that your immune system recognizes bad guys is by their marker proteins, right? You can tell good guys from bad guys by marker proteins. And we call marker proteins on bad guys, we call them antigens, all right? So what a macrophage does is swallow as many bad guys as it can, and then chop them up and float pieces of them to its own cell membrane and wear them. Okay, because that's what it reminds me of. That's why I said serial killer. Like it chops them up and then wears them so that it can show the antigens, the marker proteins from the bad guys to the next cell in sort of this stepwise immunity thing. Okay, so that's what's going on here. The macrophage is basically presenting the antigen to the helper T cell. Okay, and it got that antigen by swallowing up bad guys and chopping them up. Got it? It's basically a special enlarged phagocyte, and it displays the antigens that it got off of bad guys, and it shows those to T cells. As it shows antigens to T cells, it also secretes a chemical that activates those T cells. That chemical is called interleukin-1. So macrophage is always the first step. Swallows them, wears their antigens, presents their antigens to helper T cells. In fact, a macrophage is sometimes called an antigen-presenting cell, or APC. Next step is those helper T cells we just mentioned. They are going to show, they are basically going to kick off the two pathways I mentioned. If it's humoral immunity, they're going to show B cells how to make the right antibodies. And if it's cell-mediated immunity, they're going to show killer T cells what cells to go kill. When helper T cells dock with, I say dock because it kind of reminds me of some sort of docking operation. When helper T cells dock with B or killer T cells, they have their own chemical they secrete to activate those cells called interleukin-2. Quick side note, we were talking about viruses and some of the tricks they have. A virus that does both tricks we talked about. It does the retrovirus thing where it has RNA, and it does the lysogenic cycle thing where it kind of hits pause after it gets DNA in there, is HIV. And HIV, as we said, viruses are real specific to their host cell type. HIV is a virus that only attacks this kind of cells. HIV attacks helper T cells. And so what happens is basically on one of these waves of attacks that lysogenic viruses do, where the DNA is already in there, and all the cells go pop at once, the patient's helper T cells all go down at once. And so in those vulnerable times when their T cells are gone, AIDS victims, if they die, they tend to die from infections that wouldn't even phase someone with a full immune system, because they're unable to recognize new invading pathogens. All right, so I'm going to have to do something slightly different from how the notes look exactly. You're going to write the same stuff, but I want you to do from here, I want you to kind of make a branching path. You're going to go two ways from helper T cells. Actually, I guess from helper T cells. Because both of these things, macrophages and helper T cells, are always going to be involved. From here, we branch into two parts. So kind of from here, divide your paper into two columns. Go on the left side for this first stuff that we're about to write. On the left side of your paper, write down killer T cells. This is cell-mediated immunity. We also call them cytotoxic T cells. So what happens is the helper T cells either show or develop into killer T cells. And killer T cells, as you might imagine, they go kill stuff. Really, they're only good at killing eukaryotic stuff. Which means they're good against protists, they're good against fungi, and they're good against viruses. Not because viruses are eukaryotic, but because viruses are taking over your own cells. And so killer T cells can attack your own cells when they've basically already been lost to viruses, and they can help shut down that viral transmission process. So cytotoxic or killer T cells, super important as part of what we call cell-mediated immunity. They are also, incidentally, the problem when we have transplant rejection. When an organ transplant happens and the body's trying to basically kill the organ transplant, it's cytotoxic or killer T cells that are doing that. That's why you have to take immune-suppressing drugs when you get an organ transplant. So that's kind of the first branch. That should be on the left side of your paper. Tomorrow we'll talk humoral immunity. That'll go on the right side of your paper, okay? And that'll kind of help wrap things up. We just got kind of one more thing after that. But that's all I want to talk about for that today. Any questions?